Dear students, today we will discuss depreciation of a power plant equipments. Let's start. So today we discuss method of determining depreciation of a equipments. There is a reduction in the value of equipment of a power plant and other property of the plant every year due to depreciation. The commonly used method for determining the annual depreciation are straight line method, diminishing value method, sinking fund method. So today we discussed about straight line method and diminishing fund method. So a straight line method. In this method, a constant depreciation charge is made every year on the basis of total depreciation and useful life of the property. So let's take one example. Cost of the equipment initially suppose 1 lakh, scrap value is 10,000, and after useful life of 20 years, the annual depreciation will be 1 lakh minus 10,000, that is your scrap value, divided by the useful life, that is 20, which is equal to 4,500. So annual depreciation charge according to straight line method is given by P minus S divided by N. So P is the initial cost of the equipments, N is the useful life of the equipment in year, S is scrap or salvage value after the useful life. And if you draw a graph, you will get a straight line for this particular depreciation charge, where this portion is useful life, this portion is scrap value, and this one is total depreciation. So next one is diminishing value method. In this method, depreciation is made every year at a fixed rate on the diminished value of the equipment. In other words, depreciation charge is first applied to the initial cost of the equipment and then to its diminished value. So let's consider one example. Initial cost of the equipment suppose 10,000 and an annual rate of depreciation suppose 10%. So then the depreciation for the first year will be 10%, that's why it is 0.1 into 10,000, it is 1,000. Now value of the equipments after first year will be 10,000 minus 1,000, that is 9,000. Similarly, for the second year, annual depreciation rate is fixed. This is 10%, that's why it is 0.1 into 9,000, because it is the new value. After 1 year, it will be the 9. After 1 year, your equipments became, after initially is 10,000, so it now it became 9,000. So 0.1 into 9,000 is equal to 900. So value of equipments after second year will be 9,000 minus 900. So it became 8,100. And similarly for the third year, you can do the, similarly you can find out the, for the third year, fourth year, like that. Now, if you consider P is the capital of the equipments, N is the useful life of the equipments, S is a scrap value or salvage value after useful life, then suppose annual unit of depreciation is X. So what is the annual unit actually? So if you consider annual depreciation rate is 10%, then annual unit for this 10% will be 0.1. So X is like that. This is called annual unit. So equipment after 1 year will be P minus P into X. So we already know what is this actually. So total initial cost is P 10,000, then depreciation will be 0.1 into 10,000, this is 1,000. So 10,000 minus 1,000, that is 9,000. So we already derive, we give one example. So it is a generalized form. So P minus P into X, so it is P 1 minus X. Similarly, equipments after second year, so this is your new value now, this is your new value, that's why this is your new value after second year, and depreciation rate is X, so new value into X, so new value minus P minus Px whole to the power X. So after simplification, you will get P is equal to 1 minus X to the power whole square. So similarly, if you proceed, equipment after n year will be P 1 minus X to the power n after n years. But value of the equipments after n years is equal to the salvage value or scrap value. So your S is equal to P 1 minus X to the power n, and after simplification 1 minus X to the power n is equal to S by P, scrap value by capital value, then 1 minus X, scrap value by capital value to the power n 1 by n. So your X will be 1 minus S by P to the power 1 minus n. So depreciation after first year will be XP. So this is your P 1 plus SP 1 by n. So similarly we can find out for the second year, third year, fourth year, like that. So after 1 year, after first year is XP, so P is equal to, if you just put the value of X instead of in this place, you will get this value. Here the depreciation pattern is not a straight line, because every year some fixed rate of interest you supposed to give. So that's why it is not a straight line, it will a little bit curved line. And here this portion is your useful life, and this portion is scrap value S, and this is your total depreciation. So let's talk about one example and try to understand this whole straight line method and diminishing value method. So let's consider one example, numerical. The equipment in a power station cost 15,60,000, has a salvage value of 60,000 at the end of 25 years. So this is at the end of 25 years. Determine the depreciated value of the equipments at the end of 20 years by straight line method and by diminishing value method. So let's try to solve this problem. So in this example, the initial cost of the equipment, that is your P is given 15,60,000. and scrap value as is 60,000. This 60,000 you will get after 25 years. So useful life, this is your N is 25 years. So your first method is straight line. Straight line method. So as you know, annual depreciation is given by P minus S by N. So which is equal to 60,000 minus 60 divided by 25, which is equal to 60 which is equal to 60,000. Now you have to find out the value of the equipment after 20 years. So it will be P minus annual depreciation into year, that is your 20 years. So according to this is your straight line. So it will be 156,000 minus 60 into 20. So I think it is 3,60,000. So this is according to straight line. So let's try to solve the same problem by using diminishing method. Diminishing value method. So here annual unit depreciation, that is your X, is equal to, we already derived this one, S by P 1 by N. Okay, so this is your 160 1560, so 1 to the power 25. So this value will be, if you after simplification you will get 122. Okay, then value of the equipment after 20 years will be P1x to the power 10 to the power 20. So this is your 15,60,000, 1 x is 0.122 to the power 20, and please do the calculation here, you will get some result. Find out the result here by doing this calculation. So let's try to solve few problem based on depreciation of a equipments of a power plant, like straight line, diminishing value method. In the next class, we discuss about sinking fund method. This sinking fund method is quite similar to what you get in the operation research actually, that is replacement model. So this is whole those things, this numerical is basically come from replacement model. Thank you. Take care.